Welcome to SanfordFlipMath. This is Algebra 2. We are steadily working through the SpringBoard Algebra 2 curriculum. We are currently in Activity 5, Section 1, Arithmetic of Functions. This is all part of the whole functions chunk or unit or half unit. Just want to recap some of the things we've already done in class. This is really meant as a review type session. And so just a reminder that if you see notation that looks like this, f plus g of x, all it means is add f of x plus g of x. Sometimes you'll see that notation abbreviated f plus g. Similarly, f minus g of x. Now remember, these x's are not multiplication. This is not something you do and then distribute an x around it or anything like that. All these basically mean is you are going to subtract the two functions. Okay, and again, this could be abbreviated like that. Fg of x, this is also written f times g with the dot of x, also abbreviated f times g like that without the or of x. Okay, and in the same way, division, which is sometimes written f divided by g, either of x or not. Again, it's sometimes abbreviated f over g, or f divided by g. So again, all you're doing is either adding, subtracting, multiplying, or dividing the functions separately. Okay, that's really the whole deal. Okay, let's do just a little bit of practice with this. Okay, so these are the things we're going to do. These are the abbreviated forms. And we're not necessarily going to do it all with f and g. Let's go ahead and do f plus g. And again, this notation could look like this, and what this really means is f of x plus g of x. So all I'm going to do is substitute, whoop, I don't want that one that close, there we go, plus the other one, okay? So in this guy, we're going to put f of x. So I just follow what f of x says. In the other one, I just follow what g of x says. Well, g of x is 4 minus x. And then really all there is left to it is if I can simplify this, combine like terms, pull things together, then do that. So x squared doesn't have an extra like term, so I'm just going to write x squared. Remember, to be like terms, they have to have the same identical variables with identical exponents. So x squared works as its own thing. There's nothing else x squared here. I do have a negative 3x and a negative x, or you can think of it as a minus and a minus. And altogether, what we end up with is minus 4x, because we have a negative 3 and a negative 1. And then plus 4. There's no other like term like it. Okay. So f plus g of x is this, all simplified down. That's all there is to it. Okay. Now, what I'm going to suggest, let's do j minus g of x. And what I want to suggest is that you hit pause and then do the problem yourself and then see how it turned out. You know, you can hit play, because what I'm going to do then is do the problem. Okay, so hit pause now. That was the Dora moment. I was looking at the screen, tipping my head. Okay, so what should have happened is j of x minus g of x. And j of x minus g of x is going to look like, well, j of x is 4x minus 3. And g of x was already read, doggone it. Oh well. These things we think of. G for green, how about that? 4 minus x. Now, this is the thing that gets a little tricky with this. None of this is hard, but there are some little things you have to remember. First of all, put these parentheses here to remember to hold the chunks together. Because when we get to multiplication, it's going to be a big deal. Addition is not such a big deal. Subtraction, it's kind of a deal. Okay, so really, I'm going to rewrite this without parentheses, but when I do that, watch what happens. Okay, now I need you to look at that and think about it and decide, why does it look like that? And the thing of concern here is this plus x. So why is that plus x instead of minus x? Because just a second it was minus x. So the reason is we had to distribute this minus. It was minus 4 and minus negative x. Minus a negative is really plus. Okay, so now we're going to combine like terms. 4x plus x is 5x minus 3 minus 4, 5x minus 7. Okay, let's do a little bit of multiplication. Okay, and let's start with a clean page to do that. Let's do, we're going to do fj of x, also known as just fj. That's not a j, that's a g, sorry. Caught myself before I got myself in trouble, that's good. And really you can just say fj like this. No, it's not a Toyota fj, it looks like a Jeep, that's a different thing. So ultimately what this means is f of x times j of x. Now just to kind of throw this in here, there is really nothing special about x. These could be f of h or j of q or whatever, but all that means is the variable on the inside of it is x, that's all. Okay, so f of x times j of x. So the f of x we'll have as green, if you can see the color on your screen. So f of x is this. Okay, so I'm going to do x squared minus 3x. And j of x is 4x minus 3. Now, I just see that I'm seeing that I'm getting myself in trouble, but now Algebra 1, a big chunk of Algebra 1 is multiplying things like this, binomial. Some of you will remember the acronym FOIL, which means first, outer, inner, last. Some of you just remember this as distributing. I'm going to do this. The main focus of this is just multiplication, so don't get all freaked out if this is like mystical. But what's going to happen is first times first. Everything in this guy has to multiply everything in this guy. Okay, so what I'm going to do is first times first. X squared times 4x is 4x cubed. And then I'm going to do outer. What I mean by outer is this. So x squared times negative 3 is a minus 3x squared. Okay. And then we're going to do inner. Excuse me. So this is negative 3x times 4x. So that's minus 12x squared. And then last times last is negative 3x times negative 3, which is really plus 9x. I can do a little bit of term combining here. 4x cubed, these guys can combine. Okay, now I don't want you to get all freaked out about the mechanics of what just happened, because we will be doing this next unit, but just understand the basic focus here is this multiplication, and there is some stuff that has to happen with that, okay? All right, and then let's do one that's division, and then we'll see where we're at, okay? So let's do j, sorry, let's follow the notation in the basic sense. So we're going to do j divided by g of x, also known as j over g of x, also abbreviated just j over g. And I don't need you to write it the same way, 4 different ways every time. I just want you to get used to seeing the different kinds of notation. And really all you're going to do is j of x over g of x. Well, j of x is 4x minus 3. G of x is 4 minus x. And if you can simplify it, cool. If not, then oh well, and I don't see anything to simplify. Okay, and quick little note to self. No, you can't cancel out those 4s. Okay, so please don't do that. Okay. One other quick little note, and that is this. The book has been mentioning some domain issues. And so one of the things I want to point out is, remember that you cannot divide by 0. Anything divided by 0, undefined. Technically, 0 divided by 0 is called something called indeterminate, but the basic gist of this is don't divide by 0. So the book has been asking questions like, well, what's the domain of this? Is there something restricted from the domain? And the answer is yes, because you can't divide by 0, 4 minus x can't be 0. Well, what x value would make that happen? Well, if we add x to both sides, and then it ends up x equals 4 is forbidden, so x can't be 4. So the answer to this division is this, with a little, and oftentimes again they're asking, What's forbidden from the domain? Well, x can't be 4. Okay. All right, so the point of this video was really just to remind you of what this notation means. The notation is intended to be very intuitive. F plus g just means add f of x and g of x. The only thing that gets really tricky is that of x on the outside. So just be mindful that this is not multiplication, okay? That's the big thing. And just remember it's f of x plus g of x or f of x minus g of x. It just means add them or subtract them or multiply them or divide them, okay? Well, we're going to leave it at that. If you have any questions, you know where to find me. Thanks much. This has been SanfordFlipMath. Out. Bye.